Okay, let's look at some other types of problems. What's different about this? Well, instead of having addition, we actually have subtraction here. We still want to condense this log as a single log, so we can go ahead and rewrite that. Just recall that when we have subtraction, we actually want to divide, and the log that has the negative is the one that's going to be in the denominator. So rewriting this, we're going to have log base 2 of x minus 2 over x minus 5, and that's going to be equal to 3. We do want to proceed here and go ahead and rewrite the equation in order to eliminate the log. So I see that we have a base 2 and 3 would be our exponent. So rewriting that, we get 2 to the third power is equal to x minus 2 over x minus 5. Simplifying further, we get 8 equals x minus 2 over x minus 5. So at this point I want to solve for x. We have a little rational expression here, and we want to get x out of the denominator, so just multiply by what's in the denominator, so that would be x minus 5. I'm going to go ahead and distribute that 8 to the x and to the negative 5 here. So I'm going to get 8x minus 40 equals, and then over here we basically have some canceling going on. That's why we chose to multiply by that number. So I get x minus 2. So I'm going to continue to isolate the x. I want to get it all on one side, so I'm going to subtract x from both sides. That's going to give me 7x minus 40 equals negative 2, and then I'm going to get rid of that 40 with a plus 40. That's going to give me 7x equals 38. And then we would want to divide by 7. So I basically get x equals 38 over 7 as my answer. That's a little over 5. So I'm going to leave that as that fraction. It doesn't reduce. But there's a couple of things that I want to check, and that's if there's going to be any kind of errors. So we would want to plug this number back in and make sure that it would make our arguments for the log positive. So just checking that, log base 2 of 38 over 7 plus 2, that is greater than 0, so that's okay. And then minus log of 38 sevenths minus 5, that's going to be greater than 0 also, because 35 sevenths would be 5, so that would put us at 0. So that's a little bit more. So we're good there. The other part that I want to make sure is that we didn't get an answer of x equal to 5, because that would be a problem in the domain there. So that's another, if I had gotten 5, it would have been an extraneous solution. So that checks out for our solution for that problem. Looking at another example, it's the same kind of thing here. We're going to condense the log. I have subtraction this time, so just use your quotient property. So x plus 2 in the numerator, because that log is positive, and then we take our negative log down to the denominator. Rewriting that with our base of 4 and our exponent of 1, so 4 to the first power is going to be equal to x plus 2 over x minus 1. This would really just be 4, so I don't need to do anything with that, but I do want to multiply both sides by x minus 1 so that I can get my variable out of the denominator, and I would have to distribute that 4 to everything on the left hand side, so I would get 4x minus 4 equals x plus 2, and then I would want to get all my variables on one side. So subtracting x from both sides gives me 3x minus 4 equals 2. Adding 4 to both sides to try and isolate the x, we get 3x equals 6. And then divide both sides by 3 is our final step. So we get x equals 2. We do want to go and check and make sure that that is going to be okay for our logs. So 2 plus 2, that's fine. And log base 4 of 2 minus 1, that would be fine also. Those would all be greater than 0. And if we do check it, we end up getting, well, log base 4 on 4 is just 1, and then log base 4 on 1, well, that's just 0, so that's 1. So everything checks out there. And then the other part is I want to look at my denominator and just make sure that I don't have x equal to 1, because that is not allowed, because it would cause us to divide by 0. So this is an acceptable solution. Another example of this is the natural log. Now, a couple things that we can do here is, well, first of all, we don't need to condense it, but just think about what our base is. This is base e, because we see that ln, which means natural log. So the first thing I'm going to do here is notice that we have a 3 there in front of the natural log, and I'm going to go ahead and divide it out just to get rid of it, sort of simplify things here. So I get natural log of 2x equal to 4. And then I want to get rid of the log here, so I know that we have base e, and that this 4 is going to be our exponent based on those properties, and that's equal to 2x. So isolating our x, we would just divide by 2. Now just recall e is a number, it's 2.7 with some decimals after it. So don't be freaked out about that. And so we get x equals e to the 4th power over 2 for our final answer. Sometimes some texts will want you to leave it in this form, and sometimes a text will actually want you to find out the decimals. I'll do it just both ways just so you can see. This would be 27.3 roughly. So let's go ahead and try another one. Here I have 4 ln of 3x equals 8. Notice we have a 4 there. I'm going to isolate the natural log by dividing by 4. That gives me ln of 3x is equal to 2. Recall that we have base e here because we have the natural log. So converting to exponential form, base e squared is going to equal 3x, and then I'm just going to divide by 3 in order to solve for x. So I get x equals e squared over 3 as my final answer, and of course I could also write it in a decimal if they asked me to. Putting that in my calculator, here's what I get. 2.463 roughly. Let's take another look at another example if you need it. Notice we have 5 here. We can isolate that by dividing by 5. And rewriting, we get natural log of 2x equals 4. Since we have a natural log, that means that we have base e. So when we convert this so that we don't have log in our equation, it would be base e raised to our exponent is 4 equal to 2x, And then we would divide by 2 in order to isolate the x. So we get x equals e to the 4th power over 2. This is our final answer. We could certainly put that in our calculator and find out what the equivalent decimal is if that's what the answer wanted, or if that's what the answer choices were.